All right. All right. So in this video, I'm going to talk about R, and this is an introduction to R. In order to work with R in a computer, we need to download RStudio. It is not absolutely necessary, but it's the way that I'm going to instruct you. I believe it's the easiest and most convenient way to work with R. So you'll download RStudio. Once you have RStudio, you will fire it up, you will start it, and a window like this should appear. If your program doesn't look like this with the 4 regions, then go to this little window here that will be there, click it, and make sure that you have Show All Panes checked. That's going to make all these 4 panes show. Now, we're going to be looking at these panes across the tutorial, but for now, suffice to say that this is where I'm going to write some code sometimes. This is going to have a lot of information about the stuff that's going on right now. This is where the output is going to go, graphical output for the most part, and then some other stuff like help and other things. And this is my console. This is where the R code is going to get executed for the time being. So this is basically what's doing the blunt of the work. Now, in this console, you see a lot of information about the version of R that I have and a bunch of other things. If you want to clear that, click on this broom over here. That will actually clear the console. Now, let's do some things in R. R has, like many other languages, R has variables. Variables are like pockets, or think of you having a desk, and each drawer has a label, and you can put stuff in those drawers and refer them to the label. So for example, I can put a variable called person, and in that variable, I'm going to put a name, right? So what this says is there's a variable called person, and the word John is going to go into the drawer labeled person, or the variable labeled person, and that stays. When I do this, immediately in this environment tab here, I get values. Person has the value of John, right? So I get these two, and I get a little bit more information on that person variable. But I'm going to keep track of all the things that I define over here, which is good. Now, if I type person here just by itself, I get the contents of the variable person. That's John. Variables have to start with a letter. They can start with a dot, but that's not pretty. Not my practice, at least. Start with a letter always. Now, I can have numbers in variables. So, for example, I can have the cost of an orange. Okay, an orange is $1.99. Notice that there's no space between the less than and the minus sign here to form the arrow. Now I have orange, and if I type orange here, I'll get the price $1.99. If I make a typo, for example, right? If I make a typo, I get this error, object orang not found. So if you think that this is a variable that you should have, then check for typos. Another thing is, as I create objects here, the computer is going to help me find them. So for example, if I type purse, immediately here it says person. This square, or this figure here, is purple, indicating that it's a variable. And then it autocompletes. Now here's another interesting thing. Let's say, for example, I create a variable called tax, and that is 10%, right? The tax is 10. So I want to know what the tax is going to be on an orange. To do that, in math, and this illustrates that R can also be used as a calculator, if the orange is $1.99, I multiply this by 10 and divide by 100, right? And I get that the tax on the orange is almost 20 cents, right? Now, instead of typing all these numbers all the time, I can say, for example, orange times tax divided by 100. That gives me the value of orange, it retrieves it, which is 199, then multiplies it by the value of tax, which is 10, and divide that by 100, giving me the result. I can also put this result in the tax.orange. Now, this is a new variable name, okay? It's a different variable. It's not a mix of tax or orange. It's a whole different name. And in that name, for example, or I can say to orange with tax. So I separated the words with dots to make it clear. And I'm going to put this is the orange, the value of the orange plus the orange times tax divided by 100, right? So what I'm going to have here in the orange with tax is the actual price of the orange, the price that I pay out of pocket, because it's going to be the price of the orange plus the tax on the orange, right? So let's do orange with tax. See how the editor already starts helping me. I can click on that and it auto completes, and it tells me an orange with tax is going to be 219, right? So I can use variables and I can do computations. Of course, I can do plus, minus, multiplication, division, right? So 3 divided by 4, 0.75, 3 plus 4, 3 plus 4, 7. I can do multiplication, 3 times 4, but I can also do this, 3 raised to the power of 4, right? So I have a few more math operations, and you should get familiar with some of them and look them up. This is, excuse me, the basic console application of R. But there's a very important way in which R works, and R works over lists of numbers. Okay, and this is really important. They're called vectors. And vectors are defined with a C in front of them. So for example, I'm going to get the price of bananas in 7 supermarkets around the area, for example. Bananas, it's going to be C to indicate a vector, and then parentheses. Actually, our studio immediately puts the close parentheses there. So then let's say in one is 299, another supermarket is 295, another supermarket is 299, in another supermarket is 199, and another supermarket is 250. Okay? If I hit enter, that is the price of bananas. But this time I used a vector or a list of several values here, right? So if I type bananas, I'll get all the prices there. And if you see here in the values, bananas is numerical. It contains 5 items, 1 through 5, and this is 1, 2, 3, 4, and 5. So it tells me all that. Now, I can do stuff on variables, on these vectors. For example, I can, I don't know, add 1 to all those values. So if I say bananas plus 1, right, $1, oops, see how I had a typo. Error object not found, bananas. So bananas plus 1, every price will be up $1. And the interesting thing is I can have bananas, right? Bananas. And then what I can do is compute the tax on this, right? Times tax divided by 100. So the tax on every banana, so for example, in the first banana, a 10% tax will be this, right? A 10% tax on this banana will be this, and so on and so forth. Now, if I wanted to compute the price, the final price of the bananas, right? It will be bananas plus bananas times tax divided by 100. And this gives me, oops, again, typo, bananas. All right. This will give me the price. Now notice how fast I wrote that, right? I didn't type that. I just used the up arrow to loop through the commands that I've done in the past, and the down arrow to loop the other way. You can try that and see what happens. But here are the bananas with all the tags. I apply the tags to the whole list. R excels at having lists and applying things to lists. This is called a mapping function. So for every value, right, you do something to that value. Okay, for every value, you do something to that value. There's a reduction function, which means take all the values and give me one value. For example, sum bananas. This sums all the prices of bananas and gives me the total. If I put mean bananas, this gives me the average price for a banana, right, in this list. So you can do a lot of things with vectors. You can map, meaning for each value do something, or you can reduce, which means with all the values, produce one output. Okay, get a lot of values and produce one output. We're going to use this later when we read files and we read actually data that we want to analyze, but that's material for the next video.